Okay, let's continue. So what's the next question that we should do? Ishana, do you have any suggestions? No? So anyone has
Yes,
suggestions?
sir, but it's
Yeah.
not from geometry.
It's not from geometry. Okay, then it should wait a little bit. Aparna, do you have suggestions? Then we'll do geometry otherwise. Then we'll do that question.
Sir, you had also given the fifth question.
Fifth question.
Yes,
Same year.
fifth out.
Same. Okay.
Yes.
That's also geometry question. Okay. All right, let's see. So Ishana, what's your question? Let's see. Maybe you can try.
Yes, sir. Find the smallest integral value of m such that m square plus m plus 1 whole square till m plus 10 whole square is equal to n square. No, sir, they're separate.
Oh, m square plus.
M plus 1 whole square
Oh, okay. Right. Oh, this is number theory. Yeah, that's right. M plus 10 whole square.
is equal to n square. You have to find the smallest value and then find m plus n.
Smallest value of what? Of m or
M.
m? M. Okay.
Yes.
Uh, okay. Let's try this. Is this RMO or this is what year?
This was this year's IOQM paper.
Yes.
Oh, okay. IOQM 2022. All right. Okay, then we know this questions. I don't know this. So find the smallest m so that this is a perfect square. Right. So see, the point is that you may have to do some so there is one of the tricks that people do. Right? So there are 11 numbers. You can apply the trick like you can assume that it doesn't start from m, but it starts from m minus 5, right? And goes till m plus 5. That is fine, right? It's not a wrong assumption, right? So you take m prime equal to m minus, no, m plus 5. Yeah. Okay. And then you can do the problem. It will be easier. The calculations will become easier as you can understand. Yeah. But let's see if we can just do it like this.
Sir, I had actually solved this question halfway, but I couldn't solve.
Okay.
I couldn't find n's value. So basically, if you simplify it, you will get 11m square plus 110m plus 385.
Plus 3.
85.
Okay, that's just the sum of squares formula. So it's not even a large calculation. That's equal to n square. Okay. Yeah, so it can be done. I mean, then you apply some quadratic thing and so on, and you can do it, right? But I'm trying to do it in a slightly different way, if I can. Yeah, and if you make this substitution, then the calculation will be slightly, I mean, this number will be slightly smaller. Okay, that's all. You won't really gain anything new if it's such a simple thing. But what I'm just thinking is, what do they mean by smallest? So it's like as if it doesn't happen in the beginning, and then it. Like, so see, so this quantity, let's call this S, right? So you know that S is bigger than m square, right? S is bigger than m square. But S is less than m plus something square? Any suggestions? Or no? That's not good. Yeah. So that is not good because it is not less than m plus 10 square or something like that, right?
Sir, I had solved it by expanding also only, but I had done a mistake. I think I wrote 10. But we can first take the value of m as 1, then see the minimum value for n square. So
Okay.
we'll find out the minimum value for n. So that way we can then substitute values greater than that.
No, I don't
to find
understand.
the
Minimum
answer.
value of n? I lost you. So you put m equal to 1, then what do?
We put m equal to 1, so we find out the minimum value for n square
Okay.
because they're both positive integers that's mentioned. So
Uh-huh.
then we find out the minimum value for n.
What do you mean by minimum value for n? You get 100, you get this number. So if this is not a perfect square, most likely, then what do?
We can find out its square root approximately to
Okay.
find out the minimum value for n.
Minimum value for n. That is okay. So what do? So it's 110 plus 11. So you get 6,506. And what is going to be its square root? Roughly 24? No. 24?
22.
22? Okay. So this is 22. Okay, so you're saying that n has to be at least 22? Yes,
Yes.
that is fine, but then how does that help you in the next step?
So n square minus 385 must be a multiple of 11.
Okay, then yeah, that is because of this thing. Okay, then
Sir, after that I couldn't solve it actually.
yeah, so that's mostly just ad hoc. Yeah, no, that's always ad hoc. There's not some
Yeah,
theory.
actually 385 is also a multiple of 11, so you can take 11 common.
That's probably a simplification. Yeah, so you have to notice all that. Right, then that's nice. Yeah, but then you lose some you have some problems here, but fine. N1 square. And this can be done in maybe from here, but now you have lost that. So there is a very standard way to do this. Basically, you look at it as a quadratic equation, right? And what is it? So you want values of m and n1. So suppose some value of m and n1 work, right? So there is some n1 for which there is a solution to this equation in integers. That's all this is, right? But what does that mean? It means that the discriminant, right? This b square minus 4ac, the square root thing, that must become a perfect square. Otherwise, there's no hope of m being an integer, right? So this b square minus 4ac, this is a perfect square. Now you may think that it's again getting complicated, but you will see that it simplifies usually. Let's see if it does in this case. This thing and
Sir, but for this we have to keep putting the values, right?
no, you mean for the last equation?
Yes.
No, so that's the thing. You will see. Let's see. It converts into it because see, this does not apparently doesn't factorize so easily, and I suppose it also does, but we just don't. Maybe
So
I can.
can we say n square has to be a multiple of 11? So we have to put the values like 11, 22, 33.
Yes, you can do that, but then it becomes a lot of calculations, or maybe it does not. I don't know, right? I don't know. If you put 11, 22, those are big numbers, and then you have to solve. But we're not trying to do that because yeah, what I'm trying to say is that look, even here you can play a little smart and do something like this. This is just goes back to the thing about Diophantine equation thing, right? We want to factorize the left hand side. We want to factorize things. And we'll see how. So this is m square, and yeah, there is some problem because it doesn't factorize.
Sir, we can say that because I'm taking 11 common, that m square plus 10m plus 35 has to be a multiple of 11, right?
Yes, that's right. Yes, and from there we can say something about m square and 10m also. What it has to be modulo 11. So m square plus 10m is minus 3, so 8 mod 11, right? Or no, 9 mod 11. Just check it. Yeah, but and then yeah, all these things can be done, but there should be a simple way to say these things. Otherwise, you keep doing it. Otherwise, you have to learn more things. Yeah, 1 second. No, 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 this is not good because then we are not using the fact that there is a square. It's not just a multiple of 11, right? It's also square here. Let's look at this for a second. So there is 100 and there is, what's the difference? Minus 20. Yeah, the problem is that so what usually happens in these questions is this thing is not there, okay, or it's also a square, right? And then you can do a difference of square, then you can do the problem. Okay? Because that's where it simplifies. This discriminant actually has a very simple, makes a problem much simpler and gives you the possibilities of n1, which you can then, it's some small number of possibilities, and then you can find the values of m. But in this case, it's obviously some variation to that classical thing. So that's the thing. When you do the discriminant, somehow it becomes this difference of square, then it becomes easier to locate the possibilities. That is 11 square. I
So
mean,
actually, factorize m square plus 10m plus 35 as m plus 5 the whole square plus 10.
m plus 5.
5 whole square plus 10.
Yes.
Yes, but it does not. Yeah, but it's the same thing, right? Means that it will again be having same problem. That's what I was trying to do. But again, you can do differences. Could have done difference of square, but because this 11 you cannot do. This is, I don't know. Do you have to just put some small values and do it? It just works for some small value.
Sir, actually the values are very huge, 18 and 77.
So it's not small. So value of m is 18 and 77. All right. I mean, there is one more way. This is what is called a Pell's equation. This is the Pell's equation. And there are, it's not exactly, but I suppose it can be done by the same method. But then all the solutions, I mean, this is also, this is a number theory question. Yeah, and if you don't cancel the 11, then you have some other kind of problems.
Sir, if you just put values for m, then you'll find out that m is 18.
Yes, but yeah, that is okay. But then what about 77? Oh, 77. Okay, we just find one smallest value, right?
So 77 is the value of n.
Of n, exactly. So that's not a problem, right? Yeah, so then it is not difficult because I mean, look, what you have to know is that this has to be divisible by 11, right? And then it's not many possibilities, right? Or divisible by 11 or some modulo 11, right? So what is it? Let's work that out. Or you people just work it out. So I think, yeah, I don't think you get a very clean, thing that gives you all solutions and you find the thing. You find some properties of n, right? Like as Ishana said, that this is the multiple of 11. So you can, and we have cancelled that, and now you can put n equal to some values, and seventh value works. But uh, yeah, basically, you have to just, I'm saying that you have to just figure out what divisibility conditions are there on m and n. So like we know that n is divisible by 11. Then you can probably say more things. So if I was there, I would say, okay, let's take modulo 5. Since I already know the answer, I'm going to take modulo 7 and see. But there is, yeah, because you see, this is also divisible by 7. This thing is divisible by 7, right? So can you show that? Can you show that this is divisible by 7? It is not. Yeah, so then I don't know. You have to, like, I'm just giving suggestions, okay? This thing is plus 35 is congruent to 0 mod 11, okay? 35 is 2 mod 11, okay? So then we know that this is 0 mod 11, and yeah, and then like this one, right? M plus 5 square is congruent to 1 mod 11, right? So then basically you would know what m plus 5 has to be modulo 11, right? Because 1 mod 11 कब होता है that you can figure out, right? It's if m plus 5 is 1 mod 11, that's one possibility. There's one more possibility, just no, find out what, probably minus, okay? So you understand, right? So then you get these small possibilities that m has to be either 1, m plus 5 has to be 1, or it has to be 6, or 15 or something, and then or 11 or something, and then m plus 5 has to be 18. You'll get that, something like that, or right? That's all. So that's just a simple things you have to do. Okay, so like this has to be either 1 or -1, which is 10 modulo 11, which means that it can be 1 or 12 or things like that, multiple plus 11 23, or 1 or 10 and 22 and things, and then you subtract -12 -5 from these, and then you will get the possibilities, right? That it's -1 is out of the picture, then 10 minus 5 is either it's 5 or it is 7, or it is 22 minus 5, which is 17. Was that the answer, or 18? Something like that, or probably 23, so 23 minus 18. So it was, that you don't have to put 6, 9, 10, all those values. You don't have to check. You only have to check these values, and then you are done. Okay. So the point is that you have to use this number theory thing, right? That what is M congruent to? Okay. N, you could do that for N also, but then then you can also do, but then you have to solve quadratic equations. But if you do it for M, you have done it with a substitute, and okay. So I think this way is fine. I don't think, we need anything more, right? So we use the divisibility to reduce the choices, and you see already we are getting 23. 23 minus 5 is 18. So you will put three at the third step, you are successful, or fourth step, not bad. Okay, that is it. Let me stop here, okay, because we have to some other things. So yeah, then we'll meet tomorrow 9, okay, 9 p.m. We know what we are doing, so be ready with that. And yeah, we'll do that. We'll do at least 1 or 2 questions there, and then we'll move to RMO. Now RMO problems are looking like slightly easier. Okay, we also went into some theory, but yeah, don't mind it. Okay, then we'll meet you tomorrow again, so be ready. Good night.